So, our problem is a 70-kilogram skier glides down from the top of a hill that is 20 meters above level ground. They reach the bottom of the hill at a speed of 15 meters per second. We want to know how much mechanical energy is lost to friction between the skis and the hill on their trip from top to bottom. The skier continues to lose mechanical energy to friction once they reach level ground. Find the friction force that brings them eventually to a stop after 30 meters. And we're assuming the friction force slowing the skier down is constant during that trip. So a little sketch of this right here. We have our slope with a height 20 meters with our skier at the top with a starting from rest 0 meters per second. Down at the bottom here, moving 15 meters per second. So what I know is we have mass equals 70 kilograms, y initial equals 20 meters, final y equals 0 meters since we're at ground level now. Velocity final equals 15 meters per second at the bottom of the hill there. Initial velocity is 0 meters per second because we're starting from rest at the top. We know that gravity is 9.8 meters per second squared, and we want to find the force of friction. So I was going to use the equation for mechanical energy because that's what it's wanting us to find. So I'm going to start with the law of conservation of energy, that E initial equals E final. So I have potential energy initial plus kinetic final equals potential final plus kinetic final. So we know that there's no initial kinetic energy because we're starting from rest with a speed of 0 meters per second, so we can cancel that out. And we can also cancel out final potential because our final height is 0. So that leaves us with initial potential and final. But we also have the force of friction, so we're going to add that to the end. So the idea is that there's more potential here at the top than it is at the final, and friction will be the difference between those two numbers. So initial potential is equal to mg y naught, and that will be equal to the value of kinetic energy, which is 1/2 mv squared plus the force of friction. So now we can input our values that we know. So we have 70 kilograms for the mass, 9.8 meters per second for gravity, and an initial height of 20 meters, which will equal 1/2 of the mass of 70 kilograms and the final velocity of 15 meters per second, which will be squared, plus the force of friction. So multiplying by these, we get 13,720 joules of initial potential energy, 7,875 joules of final kinetic energy, plus the force of friction. So now we also know that friction will be the difference between these two numbers. So when I subtract 7,775 joules from 13,720 joules of potential, we get a force of friction that is equal to 5,845 joules. And this would make sense because it will provide enough force to slow down the skier by a marginal amount, but still remain with a decent speed at the end. And it'll be positive because the question is asking how much is lost, so that will end up with it being a negative force. So the second part of the problem, we want to find how much the force of friction required to stop the skier completely after a distance of 30 meters. So the setup for this, we have our flat ground with our skier going a speed of 15 meters per second and a final speed of 0 meters per second with a distance of 30 meters. So what I know from this, taking from the previous part of this problem, we have a mass of 70 kilograms, an initial velocity of 15 meters per second, final velocity of 0 meters per second. We know that x naught equals 0 for the start of the motion, and the final x marker will be 30 meters. So the free body diagram of this, we have our skier, and the only force acting on the skier is the force of friction. So using that force, we know that F net is equal to ma. And since the only force is friction, that will be equal to the force of friction. But I don't know the acceleration, so using the variables that I know, I can use the equations for motion that we have known, and I chose to use v squared equals v naught squared plus 2a x minus x naught. In solving to isolate for a, we end up with an equation of a equals v final squared minus v naught squared over 2x minus x naught. So when we multiply and put in the values that we know, we have 0 meters per second squared minus 15 for our final velocity squared over 2 30 meters minus 0 meters. We multiply this out, we get negative 3.75 meters per second squared, which is our acceleration. So now that we know acceleration, we can reapply it to this F net equals ma equation. So we have our mass of 70 kilograms times our acceleration of negative 3.75 meters per second squared. And this equals negative 262.5 joules. And this will be the force of friction required to stop the skier from their initial speed of 15 meters per second after 30 meters. So I worked this problem with the F net equals ma equals friction because I already know that F net equals ma, and I was able to determine that the force of friction is the only force acting on the object. With this in mind, I knew mass already, so I then had to find acceleration and multiply it by those to get the F net value. My result was negative 262.5 joules, which seems reasonable because acceleration is negative due to the skier slowing down, and the value will be increased by the mass, which we know from this equation. So that is all.